you for joining in. The today's topic for the this webinar is how to write scalable and testable code. Uh, as we go ahead, I'll keep explaining you what you can expect in this webinar. So it's not a small topic; it's pretty huge, and uh, y- I mean I won't be able to explain each and everything in this 1 hour session because the actual thing is quite large, quite big. So I'll try to explain all the important things as much as possible. Okay, so uh, first of all, let me introduce myself. So I am Arnold Parge. I am currently working at Nonstop IO Technologies as a tech lead. I have experience in Flutter, React, Angular, Django, and Node, and collectively around 8 years of experience. So, uh, with my experience, I have faced a lot of problems while building applications, and the most biggest or the most important one is how to build robust applications, a robust or non-breakable application. So that is the biggest problem that I have faced. And to uh, fix those problems, how to build robust and non-breakable. So when we say non-breakable application, what is the first thing that comes in our mind? We should have tests in in place in our app, right? So that is the first thing that we think of when we talk about non-breakable apps. So fine, we will write tests, but only writing test is not enough. I mean, you could write 100 and hundreds of tests, but what if they fail? There's no point of writing those tests, right? So first thing is writing test. Second is all those tests should obviously be successfully passed. But when you write test, it should also be independent. So that is what actually unit test means. So it has to be independent of other modules or other part of the code. Uh, that is what unit test mean. Okay, so the next thing that we need to do is make those things independent. Uh, so so that is how we can create robust and scalable and testable apps. So let me give you some context on what you can expect in this semi webinar. So first of all, we will do a prerequisite. We'll go through some basic concept of object-oriented programming, just to make sure that everyone in the room is on the same page and is aware of the basic core concepts of object-oriented programming, because that is very important and very useful for what I will be explaining. And then I'll explain what is scalable code and what is testable code. So one important thing is that I won't be telling you how to write tests or how to scale your code. Rather, I will explain you how to make your code ready to write test and ready to scale. So that is very important. So imagine you have to build a building, okay, and you decide to build a building of 2 floors. So you will create a foundation accordingly, right? You will create a foundation for two floors. Uh, so you do that, you create the building, and after that, if you decide to increase the number of floors, let's say you decide to add 10 more floors on top of that, then definitely the building will collapse, right? The foundation may not be able to handle that much of floors and that much of weight on it. So it is important to have a strong foundation before we build the app. I mean, before we actually start adding the flows to it. So that is very important. So that is what we'll be discussing, how to create strong foundation in the app while you are building it. So I'll explain what is scalable, how to be prepared to scale, and how to be prepared to test your code. and also the importance of scalable and testable code. And also I'll show you some couple of examples in the code. I'll try to make it more generic so that every one of you will understand. I won't be using any particular framework or a particular language. I'll mostly show you some pseudo codes so that you will understand it well, so that you don't have to check. So for example, if you are a TypeScript developer, and if I use Java, and then you may not understand some of the concept, and vice versa. So I'll try to stick to some pseudo code. Okay, so let's talk about these prerequisites. These are some basic concepts of object-oriented programming that is required for if anyone wants to speak, I'll ask them to speak. But right now, can you go on mute, please? Okay, so these are the prerequisites that we will require for building testable and scalable apps. First is inheritance. So most of you would already know this. This is just like a small revision. So inheritance means, let's say, a literal example is like a father and child. So let's say if we have a father and a child, and father has a property, let's say a car, right? So if a father has a car, then automatically that property is the child also has that property, and the child can also directly use that property, right? So that is simply inheritance. Then is the abstraction. So abstraction is basically hiding the uh, hiding the things that is not of the concern of the user or the consumer. So that is what abstraction means. So I'll try to give you a real example that we would need in our app or while we build any app. So let's say we have a front end and a back end, right? So when the front end requests for something from the back end, let's say a front end wants list of users. So front end will simply call that API and ask the backend, give me this list of users. Backend will do a lot of things, may call some multiple functions, fetch the data from the database, may have to do some authentication, and it may have to do a lot of stuff, may have to even fetch the user image from some third-party service, may have to do a lot of things. But the front end is not aware of that and is not even concerned about it. All front end wants is front end has requested something, and in response, front end wants that data. So that is what abstraction means. So this is on network layer or on a network level. So abstraction can be done on multiple levels. Even in the front end itself, we need to have some abstraction in place. So in front end, we have some modules. Let's say so UI, then that UI will communicate with some controller, and that will communicate with some other services or repos according to the architecture that we have adopted. And so that is so these are the modules that we will have. So the highest level module, which most probably is the UI, and the lowest level module will be something like a network service or a service from which you would be saving data in the local storage or uploading a file or any other network calls that you might have to do for, let's say, analytics or something. So those are lowest level modules. So the thing is that the highest level module should never be dependent on lowest level module. High level module should not be dependent on low level module. So, for example, if we have a UI and UI needs to communicate with the controller, so UI will simply say that I want list of users to show, list of users to render on the screen, right? How the controller will manage to get the user from any service or what it does, the UI is not concerned about it. So that is what abstraction means. And that will happen on multiple levels. Okay, we'll talk more about that in further slide. But the thing is, like I said, that high level module should not be dependent on low level module. So if the user interface or if the UI component is communicating with, let's say, some service or some controller to fetch the data, so it is communicating with the low level module, right? So there will be a dependency, but like I said, there should not be a dependency. So how do we eliminate that dependency? In that case, that is where the interface comes in the picture. So interface is actually, it's like a contract between two modules, a contract, a rule that needs to be followed. So when both the parties, both the modules follow that one single rule or one contract, then there is no dependency between these two modules. So interface, imagine interface. So like we have user interface, right? uh, if we use any app, any website, we have a user interface. In that interface, we have multiple components. Let's say we have a button at the top right of the screen, right? The user knows that there's a button at the top right. The app behind this interface knows there's a button at the top right. So if the user clicks on it, user is expecting some output, right? User doesn't care what is happening behind that screen. And the app, the code will somehow do something and will get the output to the user, will give the output to the user. So that is an interface, right? And that is what it actually means when we actually use interface in the code. Okay. So I hope we are clear about the basics of object-oriented principles. So now we'll talk about what is scalable code. So basically, a scalable code is simply a code that should be scalable easily. For example, if we have a button, right? Uh, if we have uh, if we have a requirement to create a button, we will build that button. Now, again, after some time, we get a new requirement of creating a similar button with a slight change in the UI. For example, we all know there are these basic kind of button like filled button, outline button, and these are the basic kind of button, right? So let's say initially we have a requirement of filled button, and then later we have a requirement of scalable button. Now, when we have the new requirement, the existing code should not be affected. So that is what scaling efficiently means. The existing code should not be affected. Now, there are different kinds of scaling. So mainly it is horizontal scaling and vertical scaling. Horizontal scaling. What does horizontal scaling mean? We have an application, okay? When we have a new feature to build in the application, so we already have some couple of features built, and now we have a complete new feature to build. So that is horizontal scaling. And vertical scaling means we have built some features, and there is some new requirement in one of the feature that we have to like we need to add some more things into that existing feature. So that is vertical scaling. So these are the types of scaling. Okay. So now I will jump into some code, some pseudo code to explain you what it will practically look like. Okay, once I explain you this code, so I'll try to write pseudo code for scaling. And once that is done, then I will open a small time for questions. Okay, so let's take this. Can you see my screen first of all? Can you read this
Increase the text.
Yes.
now, Saurabh?
Yeah, it's fine.
Yeah, cool. Okay, thanks. Okay, so this is a button. Okay, so I'll write a very simple code, not specific to any framework or a language. Just consider this as a simple class that is rendering the UI for a button. Okay. Now this is a button that is rendering. This is the render class. Sorry, render function, which is doing. So here actually it is doing a lot of stuff like it will handle on click. It will handle the styling and maybe like in the on click, it may handle some analytics and some more stuff. Okay. So it would be doing all these things. Now, like I said, if we have a new requirement if we have a requirement of a new button, okay. So right now, we have this filled button where the text is white. So you can start imagining the text is white, the background is black, okay, and the border is also black. So it is completely filled. It is a filled button. Now we want to create a outlined button. So what usually developers would do is uh, maybe in the constructor, the user will try to use a flag like is outlined. Okay, and after this, if it is outlined, then we will show black the text. If the button is outlined, the background will be white, or else it will be black. And if the button is again outlined, well, the border color will be black in both the cases. Okay, so this is what usually anyone would do if the developer is asked to do these changes, have different kind of buttons, and to use it, you would most probably do something like this: true, false. So this is a filled button, and this is outlined button. Okay, fine. You have used a flag. Cool. Now let's say there is another requirement to add another kind of button, and that would be, let's call it fancy button. Which will have a fancy kind of colors. Okay. Now in that case, what would you do? Will you add another flag like is fancy and again have nested inline conditions here? Even just by thinking about it, I'm getting a headache like how complicated this will get. So I don't even want to try that out. So that could be one possibility. The other could be, let's say you might try uh, button type, okay, which will have something like outlined or filled or fancy, okay. But even in this case, you will again have to add these checks like if button type is outlined, this, else if it is filled, this, else if fancy, this. So the problem in this particular approach is, let's say if there is again a change in the requirement of only fancy button, then I'll have to change the code here, which could affect outline and filled button as well, because everything is in one single class. So there is a high possibility that this code might break if you uh, try to change for a particular type. Okay, so how do we fix this, or how do we uh, scale this efficiently? So what we will do is, first of all, we will remove this. and this. Okay. The first thing that I would do is I'll make this abstract. So this is an abstract class now. I will actually change this to scalable. Now it is a scalable component. So first I will make this an abstract class. What is an abstract class? So in abstract class, uh, you are allowed to declare something and not define it. But it is not mandatory to only declare and not define. You can define as well if you wish. So for example, in this abstract class, I'm defining this render function, right? But I can even declare these three properties and not define it. Okay, so I have created these three properties. I've only declared it, and I will use these properties in the button here. Okay. Now, if I want to create a filled button, what I'll do is I'll create another class filled button. I will do extend, not implement. Extends custom button. Okay. Uh, just to give you an idea, the difference between extends and implements on abstract, what is the difference is that if you extend, you don't have to redefine everything. You only have to, so you are forced to define only what is not defined in your parent, like these three fields. These are not defined, so you'll have to define these three fields. But render, it is optional. If you want to redefine it, you can, but it is optional. If you don't redefine it, it will take from the parent, that is custom button. But if you do implements, then it will force you to redefine all of this, including the render. So I will extend it, not implement it. Okay, I have filled button. Now I need to define this. So for filled, the text color was white. The background color was black, and so was the border color black. That's it. So I only need to define the colors of the filled button. I don't need to again write render function and all this logic. There will be a lot of stuff that is happening in the render function or in this whole button, right? So I don't want to redo all those things. So I'll simply extend that abstract class and define the colors here. So this is a filled button. Now, like I said, if I get a requirement of outline button, we'll extend. Let me see if this auto correct. So the text will be black, the background will be white, and the border will be black. That is correct. So that will be the outline button. Okay. And if I again have to create a fancy button, then and in this case, the color will be very fancy, some random colors, let's say red, yellow, green. Okay, so this is the fancy button. Now we have these three different buttons. So if we want to use these buttons, we will directly use this button like filled button, fancy button, blah blah blah, online button and fancy button, right? Now we have these three buttons. Now if we have to change, if there is a requirement to change any particular button, let's say in fancy button, uh, there is a requirement to change the color, right? And now we don't want red for text, we want blue for some reason. right? So now I only have to change the color in fancy button class. This is not affecting any of the other buttons, and it is not affecting even this base class. So this is kind of, you know, freezed or kind of locked. You don't have to change anything here. You don't have to change any logic that is already created. So this will help you in writing individual tests for different kind of button, and also it will help you in scaling easily. And when you scale, it will make sure that the existing code or existing feature is not it is not broken, right? So it will make sure of these things. So this is actually one of the solid principles, which is called open close principle. Uh, what open close principle states that uh, the code should, or a class should be open for extension but closed for modification. Like this particular class custom button, this is open for extension. We can extend it, change the colors the way we want, but we should not modify it. But again, so this is just a principle, right? This is not something that we can enforce with code somehow. This is just a principle, and we'll have to obey it. For example, if some developer by mistakenly puts a border color to black, default color, that will happen. It is not going to throw any error, but we should try to obey this principle, and that is how we can uh, scale the code. So this is one of the example of scaling. So I have used very small basic example, but you can apply this on different level wherever you would like. So yeah, this is the example for scaling the app, scaling the code in the app. So basically, preparing to scale. Okay, cool. There is my presentation. Yeah, now does anyone have any question regarding this? I am assuming no. Okay, cool, fine. Okay, then let's move ahead. And where is my presentation? There it is. So we have checked what is scalable code, how to make code scalable. And with that, what is the advantage? Like we guarantee to not break any existing code when we have to scale, when we have to add more features, right? So that is what scaling, writing scalable code means. Now we move to testable code. So first of all, what are the types of tests that we need to write? So mainly there are three kinds of tests. The basic, so three kinds of tests. One is unit test, then widget or component or render test. So there are different terms in different framework and language, but this is the second type, component widget render test. The third is integration test. So in unit test, we need to, so the unit test means that we are testing a block of code. Okay, so that is the unit test. Let's say some function or some functionality of a particular service or something. So that is what unit test means. A widget or a component or render test means that we pick a particular component and simply test that if that component renders successfully, or if we do any change in that component, is that change rendering successfully on the screen. So that is what render test means. Then we have integration test. So this is integration test is very interesting. So integration test means that you test the complete flow of the app. Like so it actually, so it is like an automated test where you start the test, the app will open up, it will type so let's say we have a form, it will type all the details in the form, it will click submit, it will check for validations, it will check if that text is appearing on the screen. uh, it will do all those tests. But for that, uh, so basically, anywhere in the app, if the user does any action like clicking on a button or adding some details, let's say updating profile or adding some profile picture or any of those actions, right? So if we do that, most probably there is some network call happening, right? Network call for updating or using an API, or maybe uploading an image, or calling some functions of analytics. So of uh, all these functions are ultimately calling some uh, network APIs, right? So there is a dependency of network to write these tests. So how do we eliminate this dependency? So to eliminate this dependency, so it is not only about the network. Even inside the code itself, there is a dependency. Uh, like uh, like I earlier said, if we have a UI module, and then we have some low level module, so we need there is a dependency, and we need to eliminate that dependency. For that, we will use dependency injection. I will explain you in the code what does it mean and how do we do it. So dependency injection, mostly it can be done by two ways mostly. I mean, there could be more ways. The most common way is to pass that dependency via a parameter. So let's say that we have a function, and that function depends on some module, right? Or some other class. So instead of creating instance of that class inside the function itself, that will create a very strong dependency on the class, right? So instead of that, what we can do is we can create the instance of a class outside the function, and then when we call that function, we simply pass the instance of the class. That is what dependency injection means. But even in that case, somehow it is being dependent on that class, right? What if we don't want to use that class, we want to use some other class? Maybe we are using a network class which is calling an API, but we want to use some mock data. So in that case, it will be very difficult for that function to handle and check if it is coming from API or mock, or how do we do it. So in that case, to eliminate that, we have dependency inversion. So the earlier example that I told you, module should both the modules should be dependent on the third party, that is interface, that is the rule uh, that the both modules should follow. So that is what dependency inversion mean. Okay, so once we have all these things in place, that is when our code will be testable, which means that there will be no dependency in the code on like no modules will be directly dependent on each other, and we can easily test each individual modules or functions or block of code, right? So that is what a testable code means. Okay, so uh, I've explained you a lot about testable code. Now we will see some example. Okay, so I'll take the same example of network. Okay, network calls. Let's say we have a high level module. So I won't take a UI module. So UI will communicate with some controller, right? So I will simply create some controller. Okay. That controller needs to, let's call it user controller. Okay. Now we have user controller that is supposed to uh, get, update, delete users. So we will we will use an example of getting users. Okay, so let's say we have get all users. Okay, we have a function here. Then we have some low-level module. Let's call it a network service. Now in network service, we have get, which will require a URL, and then we will, for now, simply return status 200. Okay, we have this get and maybe post, but for now, let's consider get. Okay, so to use this, first of all, what we will have to do is create an instance of network service. Let's call it network equal to new network service. And then this network, using this network, we will call its URL slash users and simply return this for now. Okay, so this is how normally, usually it is. So there is some UI at the top level, or then UI is using this user controller to get the user, and it will call the get all users, and get all user will use the network instance of network service to get all the users. Network service here, this function will simply call the API and return the response. Okay. Now in this case, it is definitely like tightly dependent. So first we need to eliminate the dependency. Like I said, so most common way is to inject the dependency. Injecting the dependency using by passing it as a parameter, right? So what I'll do is I have this user controller, so I will simply get this as a parameter. Okay. Now building the network service instance is not the responsibility of user controller anymore. It will get the instance as a parameter in the controller, sorry, in the constructor, and it will simply use that network instance to call the API. Now there is no direct dependency, but still there is a dependency. No, it is not direct, but there is, because let's say we have a network service and we don't want to call the actual APIs. We want to use mock data. So in that case, what we will do? So uh, we might have to do a lot of changes here. Like this is network service. I don't know. So we will have to add a lot of checks here to check if it is to check if we want to use mock data, or do we want to use actual network calls. So to eliminate that, we will have to do dependency inversion, right? So dependency inversion, we will have to create an interface, and user controller and network service. Both of these modules will be now dependent on the interface instead of depending on each other. I'll call it a network for now, which will have get and URL string. Okay. So interface is basically uh, a set of rules that its child class needs to follow. Okay. And in the interface, you cannot define anything. You can only declare. You cannot define anything. So I'm declaring this get function that is supposed to get URL, and it will simply return the response. Now we have this interface network. I will implement iNetwork here. That is the interface. And here I will change network service to iNetwork. Now user controller is dependent on network interface. Let me call it network interface for better understanding. So user controller is now dependent on the network interface. Network service is also dependent on the network interface. So both of these modules is now dependent on network interface, right? User controller is no more dependent on network interface. It is uh, so now user. So this is what abstraction also means, that user controller only needs to get network interface, right? Or network, and it doesn't care about how it is implemented. So here it is implemented using network services. So what we will do now is we will create an instance of network interface, but of type network interface. Sorry, I might have said it wrong. We will create an instance of network service, but the type will be network interface. Okay, so network interface, let's call it network equal to new network service. So this is, if if you have not yet tried this, this is allowed because network service is it is implementing network interface. So we can create an instance of network service, but the type will be network interface. Okay. So now we are calling user controller. In here, we are passing network instance. Okay. So this network instance is of type network interface, and that is what is expected in user controller. So this is okay. It will allow this. And this with this, there is no dependency. Okay. Now let's have another implementation. Let's call it mock network service that implements network interface. Okay, we will have this same get function and return some mock data. So in this implementation, in the get function, we won't be calling any actual APIs. We won't be calling any network calls or APIs. We will simply return a mock data. We will simply return a mock JSON. So somewhere in the code, we will have to save that mock JSON data, and in this here we will have to simply return it. Okay, so we are not making any network calls in this mock network service. Now let's say if we want to use mock network service and not the actual network service. This is mock, let's call it mock network. Okay, so now to use the mock network service, you only have to pass mock network instead of network. Now again, in the user controller, the network that we are expecting is network interface. So this mock network that we are passing is of network interface. So it will allow it, and it will simply, so when it will call get function, it will call the get function of mock network service. This. So now we have eliminated the dependency, and user controller is no more aware of the implementation, like how the data is coming, how the user's data is coming, whether it is coming from the API or the mock. So yeah, we have eliminated the dependency. So this is uh, how we can eliminate the dependency and make the code more testable. So now if you want to write a test for, let's say, user controller, right? If you want to write some unit test for get all users, and so it won't only be fetching the users list and simply returning it. It might be doing some more calculations, right, after getting this data. So let's say we have some users here, and Now, uh, do some operation on users and then return the users. Okay. So all of this will get tested. And when we run that test, instead of actual this instance, network instance, we will be using mock instance. But when we use mock instance, the user controller will not be affected. Okay, so this is how we can create testable apps and testable code. This particular code is more testable than the earlier that we had written without dependency injection, because that was dependent on network. And if anything changes in the backend, then that will create a lot of problem, and then the tests will ultimately fail. And with that, we cannot assure that our application is robust and well testable. Okay. Cool. Any questions in this?
I have a question. Why did we declare network interface? I mean, when we create that object, we can always extend network service itself and return, like override the get function to return mock data.
I'm sorry, can you please repeat again?
Why do we need this network interface? I mean, when we create this, what do you say, network service class, sorry, user controller class, if we take network service as a parameter, then we
Mhm.
can just provide a different implementation of network service that extends network service but overrides the get method.
Yeah, we can do that as well. That is also fine. But uh, that's fine. But see, so what will happen is, so you are creating this class, right? Let's say networks. This is the network, right? So let's call it mock2. And you are saying we'll extend the network service, right?
Yep.
And that here we will use network service.
Hmm.
Okay. Now, in this case, this will not enforce you to redefine get. What, so for example, let's say we have a post, and we will do somewhat similar thing here. Let's say you override get, okay, and return mock, but it will not enforce you to override post because you are extending it. It is up to you. It is optional.
We can
Okay,
just do implements as well.
I'm sorry, what?
We can just do implements as well. I think in languages like JavaScript, it allows you to do both. So if you do implements, it will force
I'm
you
not
to.
sure if you can implement a class. This is a class.
I am aware of languages that have this distinction that if you just write implement, it will force you to implement the entire interface of that class.
So if you are anyways supposed to redefine everything, then why not have an interface where you have only declared it?
Because it is not giving me any benefit. Like having a third thing, but it does not give me any benefit. So why should I have a third thing?
Okay, so this is very important. I know where you're coming from, and even I had a kind of similar opinion about interface, where literally I used to think interface is the most useless thing that is in the programming or coding or developing world, because there is nothing. We are only declaring it and doing nothing inside it. But it is actually very useful if you think about it. I mean, it's a long discussion. So I would suggest you check about solid principles and how they are followed, especially dependency inversion. That will give you an idea about why we use interface and how is it useful in this scenario. So what the approach that you have said, इससे काम हो जाएगा, but there could be some problems with this. Like I said, there's one of the problem that I showed you. There could be some more problems as well. And you're saying to implement it instead of extending it. Uh, there will be some issues with that. I mean, we can discuss it further, but that will take a lot of time. Okay. Thanks, Emil, for the question. But so I would recommend you to read about solid principles and dependency inversion. You will have some idea about them. Any other questions? Okay, I'm assuming no more questions. Fine. Okay, so we talked about testable code. What are the types of testable code? Sorry, what are the types of tests? How to make it testable by eliminating dependency and using dependency inversion, and some example using the network service. Okay. So, well, this approach has advantages, like I told you, like scale fast without breaking any existing changes, any existing features, and also eliminating dependency on any level. So I have showed you an example of eliminating the network dependency, but you can also eliminate dependency in the modules itself, so that one module is not completely dependent on other modules. We have those advantages by which we can make robust and strong application, unbreakable application. But we also have some small disadvantages. I wouldn't call it disadvantages, but so we need to consider this as well when we use this approach. So one of the biggest thing is developer skills. The developer that is involved in building that application needs to have some strong object-oriented concepts clear when building or taking this approach. And that is one. The other is time. So when we use this approach, so I showed you a very small example, but when we make the whole code testable and scalable, um, it takes a bit more time than usual when you have to build something. So the time is also one of the things that we need to consider while taking this approach. But I honestly don't find this as a disadvantage. Just for the sake of columns, I have written it there, but it is something to consider when we take this approach. Okay, yeah, that's all. So thank you for joining. If you have if you have any question, you can ask. And so this is the QR code that you can scan. You can follow me if you have any question. And also, I was actually planning to show an actual code, an actual app that will run without network and perform test. And it will also run the app, the complete app, without network dependency. I could have showed you the code in deep. I was actually planning for that, but I I think we don't have that much time. So I will be uploading a video of uh, this complete example where I'll show how to write testable code, scalable code, and the ultimate output. I'll run the complete app, and that I'll upload somewhere, maybe on Instagram, Twitter, somewhere. So follow me. Make sure that you see that. I'm sorry I could not fit that in this 1 hour session, but I'll definitely upload that. So do follow us, follow me, follow my team, and thank you.